Okay, how you guys doing there? Hopefully well. Last video of the semester, we have the exam review video that we're going to do right here. Remember, your exam is next Monday. I'm not sure exactly what time, to be honest with you guys, but I'm sending emails every single day that tell you what time your exams are, so just make sure that you do your exam on time, okay? I've had a lot of students, not as much with you guys as much, but I've had several students in my other classes that forget about their exams, and I cut them some slack one time, but you got to take your exam on time, okay? So make sure you take it next Monday, December 14th at the appropriate time. Just keep checking your emails. Hopefully it tells you when the times are. The exam, it'll be on Schoology, and what we'll do is you can either, or it'll be at the very bottom on Schoology, at the bottom of the list of class materials. That's where this there's a review sheet there right now that you can either print that off, or if you might want to write down the questions so you can follow along with the questions while we work through the reviews here on the video. So anyhow, the review sheet has 16 questions, the test has 16 questions. Like usual, this is not the test, but very similar questions, okay? So if it's on the review, it's on the test. So just make sure that you have this down really well. So let's work through this review sheet, okay? So I will give you a a filled out unit circle that you can use on your exam. Okay, so they ask us on this one, find the exact value of the inverse sine of negative radical 2 over 2, okay? So if you remember, when you look at your unit circle, okay, we look for where is sine negative radical 2 over 2, okay? Well, there are two places where sine is negative radical 2 over 2, at 315 degrees and at 225 degrees, okay? You don't need to do all of this stuff, okay? But I just do want you to understand that if you look at your unit circle, at 225 degrees and at 315 degrees, it is negative radical 2 over 2, the sine is, okay? We cross out 225 though, because if you remember, inverse sine, you're only supposed to look at the right-hand side of the unit circle. And, and 225 is on the left-hand side of the unit circle. So at 315 degrees, but I want it in radians. So the radians, it says 7 pi over 4. Well, that's not the right answer, okay? The reason is, it's not just good enough to say on the right side of the unit circle, okay? What you need to understand is if this right here is 7 pi over 4, this right here is negative pi over 4. So the answer is negative pi over 4, okay? It's not just the right side of the unit circle, it's between negative pi over 2 and positive pi over 2. And 7/4 pi is too big, okay? So you have to rename it. You're looking in the right spot, you have to rename it though, okay? Number 2, it says inverse cosine of the cosine of 9 pi over 8, okay? Well, what we do on these is they just cancel these off, and we put down 9 pi over 8, and that may or may not be the right answer, okay? So what I'm going to do is I'm just going to put, where is 9 8? Now you might be going, well, it's not on the unit circle. I know it's not, okay? But you should understand 8 eighths is a whole pi, so 9 eighths is right about there, okay? That's where it would be. So is that the right spot to be looking at, okay? No. For inverse cosine, you have to look at the top half of the unit circle, and that's on the bottom half. So we need to put in another angle that has the same cosine value. Cosine's left and right. Where can I put a dot that has the exact same cosine value? Right here. Okay, they both went left the same amount. I remember thinking, well, that one went up, that one went down. Well, that's the sine. Sine is y, x is cosine. Okay, so if this right here is a whole pi, and this is another eighth of a pi, okay, so this right here, this little slice right here is 1/8 of a pi, because a whole pi and 1/8 of a pi is 9 eighths. This right here is also 1/8 of a pi. So in order to get here, it would be 7 pi over 8, okay? 7 eighths, 1/8, 1/8, okay? This is 1/8, this is 1/8. So to get to that, that's a tougher one, okay? I will tell you this, I think the one on the test is a little bit easier, okay? Okay, number 3. This is a simple one. Sine of the inverse sine of 0.7, okay? Now, we've switched them. Instead of saying inverse trig function, then trig function, we have the trig function, inverse trig function, and they just cancel out for the most part, okay? I'm going to make this a 2-part question. These cancel out, you get an answer of 0.7, and that's the right answer. So, because you can take the sine of any number that exists. If this would have been 1.7 though, do these just cancel out and you get an answer of 1.7? The answer is no, because I'm asking you to take the sine of a number that doesn't exist. Where is sine 1.7? Nowhere. It's too big, okay? So as long as this number is between -1 and +1, they just cancel out. Okay, so it's just 0.7. Number 4. Find the inverse of f of x is 3 tangent. 3 tangent of what? Theta minus 7. Okay, so first I'll make it y equals 3 tangent. I'm going to make that an x. It doesn't really matter, okay? Now to find the inverse, remember you switch x and y. Change f of x to y, then change x and y. So x equals 3 tangent y minus 7, and then solve for y. So we add 7. So we have x plus 7 equals 3 tangent y. And be careful here. If you want to get y by itself, you can't divide by 3 tangent. That doesn't make sense, okay? You divide by 3. Dividing by 3 tangent doesn't make sense. So we have x plus 7 over 3 equals the tangent of y. Give me a second, the phone's ringing. I'll be right back. Okay, just my kids. I'll call them back in a few minutes. Okay? All right, so how do we get rid of tangent? We take the inverse tangent of each side. So inverse tangent of x plus 7 over 3 equals, if I take the inverse tangent of the tangent, they cancel and off with y. Now, I shouldn't say equals y. I should say f of x, but not even f of x. F inverse, that looks terrible. F inverse of x equals inverse tangent of x plus 7 over 3. I switch sides here. That's okay. Okay? All right. Let's look at number 5. Question number 5. Can you still see me on the screen? Yes, you can. Okay. So tangent, cosine, inverse, radical 3 over 2. Okay, so what they're asking is this, okay? They're saying cosine is radical 3 over 2. I want to know what the tangent is, okay? So we look at our unit circle. Where is cosine radical 3 over 2? Well, there's 2 spots, at 30 degrees and at 330 degrees. Well, for inverse cosine, you're only allowed to look at the top half, so it's at 30 degrees is where you need to look. So this is 30 degrees. What's the tangent at 30 degrees? Radical 3 over 3. Okay? Number 6, cosine inverse sine of what? 2/3. Okay, your unit circle is no good on this one, okay? Because there's nowhere on unit circle where you see sine 2/3. So we draw a picture, okay? Sine is positive 2/3, sine is positive up, but we want to be on the right, so let's put it over here. Theta right there. Okay, sine is opposite over hypotenuse, 2 over 3. Let's find out what x is. So we use the Pythagorean theorem, x squared plus 2 squared equals 3 squared, x squared plus 4 equals 9, subtract 4 to each side, x squared is 5, square root it, x equals plus or minus radical 5. So it's plus or minus radical 5, but it's plus radical 5 because it's to the right. I want to know what cosine is. Cosine is adjacent over hypotenuse, so radical 5 over 3. Okay? So it's not on the unit circle, draw a picture. Okay. Almost halfway done. Number 7. Let's get some trig identities going here. Okay, establish identity. And these are not the identities. These are not going to be the ones that are on the test, but they're very similar. Tangent plus cotangent. And I'm putting the thetas in. You don't necessarily have to. You guys know that, though. Okay, I'm going to leave them out from this point forward, I think. Okay, I'm going to change this side because it looks a whole lot messier than that. So I'm going to change everything to sines and cosines. So cosine, tangent sine over cosine. Cotangent is cosine over sine. Okay. I could distribute if I wanted to. I'm not going to do that. I'm going to get a common denominator. Common denominator of cosine sine is sine cosine, or cosine sine, it doesn't matter. Okay. To make cosine sine cosine, we times by sine, so times the top by sine, we get sine squared. To make sine sine cosine, we times cosine, so times that by cosine, we get cosine squared. Okay, we've got a common denominator, so I can add these up, and sine squared plus cosine squared is 1. So 1 over sine cosine. Make cosine a fraction, cosine over 1. So cosine times 1 is cosine. 1 times sine cosine is sine cosine. The cosines cancel. Be careful, you're not left with sine, you're left with 1 over sine. And 1 over sine is cosecant. Okay? So cosecant equals cosecant. Number 8. Okay, cosecant minus 1, or cosecant plus 1 equals 1 minus sine, and 1 plus sine. Okay, this is a one-stepper, okay? If you remember from our videos, the skeletons are the same, meaning there's 2 terms, 2 terms, 2 terms, 2 terms, minus plus, minus plus. That generally looks kind of like that. So what I'm going to do is I'm going to change these individually into that. How do you make cosecant into 1? How do you make anything 1? you divide it by itself. So divide that by cosecant, divide everything by cosecant. So the cosecant divided by cosecant, minus 1 divided by cosecant, over cosecant divided by cosecant, plus 1 divided by cosecant. These cancel out to get 1. 1 minus 1 over cosecant is sine. This is 1 plus sine. Okay? That was a simple one. Number 9. Secant minus cosecant over secant cosecant equals sine minus cosine. There's more than one way you can do this one. Here's what I'm going to do. Secant on bottom is the same as cosine on top. So I'm going to put cosine on top, and cosecant on bottom is the same as sine on top. So cosine sine times secant minus cosecant. Okay, so I move secant to the top, turns to cosine, and cosecant to the top turns to sine, because they're reciprocals. Okay, and I'm going to do this, cosine sine, I'm going to change the secant into 1 over cosine, and cosecant is 1 over sine. If I distribute this, cosine sine times 1 is cosine sine over cosine. Cosine sine times 1 is cosine sine over sine. The cosines cancel, the sines cancel, we have sine minus cosine equals sine minus cosine. Okay? All right, number 10. Okay, the exact values. Okay, if you note on the top of the back of the review sheet, I am going to give you 3 of the 6 sum and difference formulas. I'm going to give you the sum formulas, not the difference ones. Okay, you should be able to come up with the difference ones on your own. You just change the signs. Okay, cosine alpha, cosine beta, minus sine alpha, sine beta, sine of alpha plus beta, sine alpha, cosine beta, plus cosine alpha sine beta, and tangent of alpha plus beta is tangent alpha plus tangent of beta, or 1 minus tangent of alpha times tangent of beta. So, number 10, I want the sine of 15 degrees. Okay, well, that's the same as the sine of, I'm going to do 45 degrees minus 30 degrees. Okay, so so I'm going to use this one, but it's going to be subtract this time. So it's a sine of 45 degrees times a cosine of the other angle, 30 degrees, plus, no, remember, I'm doing minus, so I got to change it to minus. Again, I'm only going to give you 3 of them. You got to remember, if you're going to switch them, you got to switch it here. And then the cosine of the first angle, cosine of 45 degrees, times the sine of the second angle, 30 degrees. Okay? Sine of 45 is radical 2 over 2. Cosine of 30 degrees is radical 3 over 2. We're looking at our unit circle now. Cosine of 45 degrees is radical 2 over 2. Sine of 30 degrees is a half. 2 times 2 is 4. 2 times 2 is 4. It's going to be all over 4. 2 times 3 is radical 6. Minus radical 2 times 1 is radical 2. Okay, so radical 6 minus radical 2, all of that over 4. Okay? Number 11. Cosine of 105. Well, I'm going to make it the cosine of 60 degrees plus 45 degrees. Okay, there's more than one way we could do it. That's the way I'm going to do it. Okay, 60 and 45. So it's going to be this one here, and I'm not going to change it because it's plus and it's plus. So it's going to be the cosine of 60 times the cosine of 45 minus the sine of 60 times the sine of 45. Okay, I'm just plugging them in the formulas. Cosine of 60 degrees is a half. Cosine of 45 degrees is radical 2 over 2. Sine of 60 degrees is radical 3 over 2. Sine of 45 is radical 2 over 2. Again, 2 times 2 is 4. It's going to be 4 is on bottom. 1 times radical 2 is radical 2. Minus radical 2 times radical 3 is radical 6. So radical 2 minus radical 6, all of that over 4. Okay? All right. And number 12, tangent of 75 degrees. Okay, tangent of 75. I'm going to make it the tangent of 45 degrees plus 30 degrees. Okay? All right, so I can use this one right here. So it's the same as the tangent of 45 degrees plus the tangent of 30 degrees over 1 minus the tangent of 45 degrees times the tangent of 30 degrees. Okay? And tangent of 45 degrees is 1 plus the tangent of 30 degrees is radical 3 over 3 over 1 minus 1 times radical 3 over 3. Okay? I'm going to make 1 a fraction. 1 over 1, which is the same as 3 over 3. So 3 over 3 plus radical 3 over 3, 3 over 3 minus 1 times radical 3 over 3 is radical 3 over 3. Now, since we have the same denominators everywhere, I can cross each of them out. So we have 3 plus radical 3 over 3 minus radical 3. We can't have radicals on bottom, though. So we times the top and bottom by the conjugate of the bottom. The conjugate of the bottom is 3 plus radical 3. Okay. So we FOIL this out. 3 times 3 is 9. 3 times radical 3 is 3 radical 3. Inners are 3 radical 3. Radical 3 times radical 3 is radical 9, which is 3. When we do conjugates, we just do our first and our last. 3 times 3 is 9. Last, negative times positive is a negative. Radical 3 times radical 3 is radical 9, which is 3. Clean this up. 9 and 3 is 12. 3 radical 3 and 3 radical 3 is 6 radical 3's. Over 9 minus 3 is 6. Divide each of these by 6, you have 2 plus 1 radical 3. So 2 plus radical 3. Okay? A little more work on the tangent ones. Okay? All right. But again, I will give you the sum formulas, but not the difference. To find the difference ones, you just change the signs. Okay? Okay, number 13. Ooh, I shouldn't have erased that. Gosh darn it. Okay. It says cosine, cosine, minus sine, sine. Okay? So if you look at this, it looks like the reverse of the very first function, cosine. I gave you cosine of alpha plus beta. That's cosine alpha, cosine beta, minus sine alpha, sine beta. So when they gave us this, it says cosine 80, cosine 10 minus sine 80, sine 10. It looks like this formula backwards, so it's the same as the cosine of the two angles added together, 80 plus 10. So the cosine of 90 degrees. The cosine of 90 degrees is 0. If you look at a unit circle, cosine of 90 degrees is 0. Okay, 3 algebra questions, then we're done. Okay, so solve on the interval from 0 to 2 pi, including 0 but not 2 pi. So we have 2 cosine theta plus 7 is 6. Stuff that we did on section 3.8 is not on this, okay? But from section 3.7 it is. In other words, 3.8 is the one that has some factoring and stuff like that. There's no factoring on this. So we minus 7, 2 cosine theta, 6 minus 7 is negative 1, divided by 2, divided by 2. Cosine theta is negative 1/2. And then we looked at a unit circle. Where's cosine negative 1/2? 2 spots, okay? At 2 pi over 3 and 4 pi over 3. $15. 4 sine squared is 1. So we divide by 4, sine squared theta is 1/4. Do not make it a decimal, it's easier if you leave it in fraction. Square root, sine of theta equals the square root of 1 is 1. Square root of 4 is 2. But it's plus or minus, don't forget the plus or minus. So where is sine either positive half or negative half? There's actually 4 answers, okay? Sine is positive half or negative half. It's positive half at pi over 6 and at 5 pi over 6. That's where it's positive half. It's negative half at 7 pi over 6 and at 11 pi over 6. Okay, so those are the 4 answers. Pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. Okay, last one, 16. Okay, 16 we have what? 5 cosecant theta. Minus 3 is 2, is that what it says? Minus 3 equals 2. Okay, so we need to solve this. Add 3 to each side, that's easy. 5 cosecant theta equals 2 plus 3 is 5. Divide by 5, that's not hard either. Cosecant of theta is 5 divided by 5, which is 1. If cosecant's 1, I'm going to flip this, and flip this. Flip cosecant, and it's sine. And flip 1, it's still 1. Where is sine 1? Pi over 2. Pi over 2 sine is 1. Okay, that's it. So make sure you study. Again, exam is next Monday, December 14th. I'm not sure exactly the time, but you'll check your emails and it'll tell you when the time is. If you have questions, email me and ask me, and I'll get back to you as soon as I can. And we'll talk to you guys later. See ya.